In this video, we'll take a look at solving a system of three linear equations in three unknowns. And this is what that looks like. We've only seen the unknowns x and y, so this is when we add in the unknown value of z and the constant now becomes a d. Before we can work with Cramers' rule for 3x3 determinants, we need to actually learn how to evaluate a 3x3 determinant. And I'm going to show you two different methods today. In the first method, notice we have here a 3x3 determinant. We also have, so that alone is a 3x3 determinant. Okay, so that's how it will look. What you do in this particular method is you copy the first column on the outside. So that's just a copy over there. And you copy the second column beside that. And it's really great if you can keep even spacing, because you will see why when I start to show you what we need to do to evaluate this 3x3 determinant. If you recall from 2x2 determinants that there was a principal diagonal and a secondary diagonal, but there was only one of each. In the 3x3, there are three principal diagonals that we need to add together, and then there are three secondary diagonals that we need to subtract from that sum. So let's take a look at the first principal diagonal, which runs from the top left corner down here. So the values are A1 times B2 times C3. We will add to that the second principal diagonal, which is here. And this is why we copied the first column over. So this is B1 times C2 times A3 plus, and we will add to that the product of the third principal diagonal. So that is C1 times A2 times B3. These are three principal diagonals. And remember, we are multiplying A1 times B2 times C3, etc. Now what we need to do is subtract all of the secondary diagonals. So there is one way that we can do that. We should put a subtract and a big bracket. And we will take a look at what the secondary diagonals are. The first secondary diagonal runs this way. Okay, so it is A3 times B2 times C1. Since I put the subtract on the outside of the brackets, I'm putting addition on the inside. What is the second secondary diagonal? It's here. So that is B3 times C2 times A1 plus the third secondary diagonal right there. Okay, so it is C3 times A2 times B1. Now, notice if I didn't have the big square brackets, that this would be the first three principal diagonals subtracting each of the secondary diagonals. So that's a way you can do it too. You don't need the brackets as long as you subtract all of the secondary diagonals. The brackets just let me add them up together and subtract them as one value. So that's the process for evaluating a 3x3 determinant. Let's take a look at a numerical example. And so I'll put it there. All right, I need to find each of the three principal diagonals. This will be 3 times minus 2 times 1. That is right there. And we will add to it the next principal diagonal, which is 2 times 0 times 1. You really have to watch your signs with this. The third principal diagonal is minus 1 times 4 times 5. And now I will subtract the sum of the secondary diagonals. So the first secondary diagonal is here. That is equal to 1 times minus 2 times minus 1. We will add to that the second secondary diagonal. That is 5 times 0 times 3. And we will add to that the third secondary diagonal. And so that is 1 times 4 times 2. All right, now I just need to do some number crunching here, and in the first one we get minus 6. In the second one we get 0, because 2 times 0 times 1 is 0. In the third one we get minus 20. Subtract. First value here is 2 plus 0 plus 8. Okay, so we have minus 6 subtract 20, which is minus 26. Subtract what's in the brackets, 10. Minus 26 subtract 10 is equal to minus 36. That's the value of this 3 by 3 determinant. Okay, now just in case someone is thinking maybe there's another way and they want to see a different way, or they've learned another way but they can't quite remember it, I want to show you the second method that I know of. And it involves taking a look at a first column. I am going to take each of these values separately and multiply by the leftover 2 by 2. So here's how the first one will look. I will take A1 and multiply it by the leftover 2 by 2 is, if I cross out the row and the column that A1 sits in, you can see a leftover 2 by 2. Right? Okay. And that's the positive of that value, which will be whatever it is. Now for the second term, I want to erase that because the second term is, this is very important, subtract the second value multiplied by the 2 by 2 determinant that's left over if we cross off its column and row. So that's B1, B3, C1, C3. For the third value, we will add the third in that column multiplied by the 2 by 2 determinant that is left when you cross off its row and column. So that's B1, B2, C1, C2. Okay, so this is kind of not a bad way either. It doesn't involve copying the first two columns over. There is this key feature that the middle term is the opposite sign to what you're doing a subtraction there. Okay, so let's take a look at this process with our numerical values down here. All right, I'm going to take the first value. It's a positive 3, so it's 3 multiplied by the 2 by 2 determinant that's left over when I cross off the row and column that 3 sit in, and we don't need these for this process. So we're left with minus 2, 5, 0, 1. Okay, now to do the second term, I want to, it's a 4, but remember it's subtract or it's becoming a negative. When you cross off the row and column that 4 is in, we have this 2 by 2. 2, negative 1, 5, 1. Okay, and going to the third term in here, plus 1 times this one. We'll cross off its row and column to visually see the 2 by 2. 2 minus 1 minus 2, 0. Okay, so now we just have to evaluate these 2 by 2's and multiply them by the value that we have in front of it. So 3 is multiplied by minus 2 times 1, right? Principal diagonal. So minus 2, subtract 5 times 0, subtract 0. Minus 4 is multiplied by 2, subtract minus 5. Right? That's 2 times 1 to get 2 times 1 to get this 2. And 5 times minus 1 to get this minus 5 with a subtract between. And plus 1 times 2 times 0, which is 0, subtract 2, right? Because negative 2 times negative 1 is positive 2. All right. 3 multiplied by negative 2, subtract 4 multiplied by 7, plus 1 multiplied by negative 2. Okay, this is negative 6, subtract 28, subtract 2. And that is equal to negative 36, which is the same we got last time. This was just a different method. Okay, so now that you have seen how to evaluate a 3 by 3 determinant, then when you see Cramer's rule, which looks like this, you can actually find each of the 3 values x, y, and z in a system of 3 linear equations with 3 unknowns, the unknowns being x, y, and z. The general form of the equation should be ax plus by plus cz equals d. So we've added one more unknown. The c is not the constant anymore. It's the coefficient of the third unknown, and therefore the constant now is d in this situation. So notice something about these 3. The denominator, which is actually called the determinant of the system of linear equations. These are all identical. The a's, the b's, the c's. Okay? When we're solving for x, its coefficient is a, right? So when we're solving for x, the a column is changed to the d's, but b's and c's remain the same. When we're solving for y, its coefficient is b. The b column changes to d's, but a and c remain the same. And when we are solving for z, its coefficient is c. The c column changes to d's, but a and b remain the same. So that's just the pattern I wanted to point out. So let's see. I'm going to just take off that messy stuff, and now we are going to solve a system using this. Now, when you're solving a system of linear equations, 3 linear equations with 3 unknowns, most likely you will have to solve for 2 of the unknowns using Cramer's rule. The third one you could do by substitution, because then it will be the only unknown left. So let's take a look at this system right here and make sure that we have each of our 3 equations in the general form. We have the x term, the y term, the z equals the d. Okay, x, y, z equals d. X, y, z equals d. Good. All 3 are in general form and they are ready to go. So let's solve for x first. X will be equal to, and I'm going to have to write out 2 3 by 3's, right? one over the other. Notice that it is 2 3x3 determinants and with a division in between. So you get this value, you get this value, you perform the division. Okay? All right. Okay. So let's fill in the values now. When I am solving for x, remember this first column right here is going to be the d values. -5, watch your signs, 9 and -6. And then this is the b and this is the c. So 6 -3, 3. And -1, 2, -1. Okay. Down below, it's just going to be the A's, the B's, and the C's. So the A's is 3 -2, 1. These are all the A's right here. And then the B's, 6 -3, 3. In fact, it's a copy of the column above. And -1, 2, -1. All right. Now, we're going to solve this by using method number 1. Then we'll do y by using method number 2. Okay, hopefully I have enough room. I need to multiply 5 times -3, or sorry, -5 times -3 times -1. It will be a -15. And then I need to add to that the product. Oh, I didn't do one thing first. Hold on. Let's just copy off the first two columns so that we can easily see our values. Okay. Now, I better make some space. Okay, so I'm going to start over here. So x is equal to, I need to do this first diagonal -15 plus the next diagonal, 6 times 2 times -6. It will be a -72. 6 times 6 times 2 plus the next one, -1 times 9 times 3, which is -27. And we will subtract from that the sum of the secondary diagonals. -1 times -3, this is the first secondary diagonal here. It'll be a negative, and it will be a negative 6 times 18. 6 times 3 times 1. Add to that the next one. It will be a negative 5 times 2 times 3. So that is 30, -30. And add to that the last one. It will also be a negative 6 times 9 times 1. 54. And close the bracket. Okay. X is, oh, and we have to do the next line underneath it too. So that's the top one. We need to do the denominator determinant as well. So the first principal diagonal, 3 times -3 times -1. This is 9. Add to that the next principal diagonal, 6 times 2 times 1, which is 12. Add to that the third principal diagonal, -1 times -2 times 3. This will be a +6. Subtract from that the first secondary diagonal. And just to catch up with me there, I am there. This will be a +3. And the next one will be 3 times 2 times 3. So 18 plus, and the next one will be 6 times minus 2 times minus 1. That's positive 12. All right, now we just have some addition, subtraction to do. And I'm going to write these lines without brackets now, so you can see this will be minus 15, subtract 72, subtract 27. When I subtract a negative 18, it's an add 18. When I subtract negative 30, it's an add 30. And when I subtract negative 54, it's an add 54. Remember, that is all over whatever is in the denominator. 9 plus 12 plus 6, subtract 3, subtract 18, subtract 12. All right, a little more space. Okay. Get your calculator. Let's do the top line. Minus 15, subtract 72, subtract 27, plus 18, plus 30, plus 54 equals minus 12 over the denominator 9 plus 12 plus 6, subtract 3, subtract 18, subtract 12 is minus 6. And minus 12 divided by minus 6 equals 2. So far, our solution, which looks like x, y, z, right, will be 2, and we have the y and the z still to figure out. Okay, next we need to solve for one of the other variables, y or z. So let's just move on to y, and we'll solve for y. And the equation for y is that we have the second column, the b column here, has changed to the d's. So it will be in this one, minus 5, 9, minus 6. The a's will stay here, 3, minus 2, 1, and the c's will stay here, minus 1, 2, minus 1. In the denominator, in fact, we don't need to calculate this again. If we are confident in the first time we did it, we found out that the bottom one, which repeats for all three values, is actually equal to minus 6. So we'll save us some time. This will be over minus 6. So now let's evaluate this 3 by 3 determinant using method number 2, which means I want to multiply 3, the first value, 3 by the 2 by 2 determinant that's left when we cross off its row and column, right? And so that is equal to, we've got 9, 2, and minus 6, minus 1. All right, I shouldn't have drawn on them because now I've made a mess of them. Let's just... All right, so quickly clean that up. Now we subtract and we move on to the second value. It is a negative 2. Remember, it's always a subtract no matter what the sign is here. And what is the 2 by 2 left over if we cross off the row and column that negative 2 is in? We end up with minus 5 and minus 1 above and minus 6 and minus 1 below. And now we go down to the bottom value, which is plus 1 multiplied by the row and column. We cross off the row and column for it, and we are left with minus 5 minus 1, 9, 2. Okay, so we have to multiply 3 by, Well, 9 times minus 1, this principal diagonal, is minus 9, subtract negative 12. Subtract negative 2 multiplied by minus 5 times minus 1 right here. It's 5. Subtract minus 6 times minus 1 is positive 6. Plus 1 times minus 5 times 2 is minus 10. Subtract minus 9. Okay, a little bit of work now to get rid of some brackets. Oh, and also remember that that is all over minus 6, right? That's just the top one. Space. Okay, so this is equal to 3 multiplied by minus 9 plus 12 is 3. Subtract negative 2 multiplied by 5, subtract 6, which is minus 1, plus 1 multiplied by minus 10 plus 9, which is minus 1. And again, that is all over negative 6. So this is 9, subtract 2, subtract 1, all over negative 6, which is equal to 6 over negative 6, which is equal to negative 1. So our y value is negative 1. Y equals negative 1. We had up there that x was equal to 2 so far. I'll just double check. X is 2, y is negative 1. Now, to solve for z, we can go to any one of these equations and sub in a 2 and a negative 1. Z will be the only unknown. Solve for z. All right, so that's one way to go. Now, what I suggest that you do is pause the video and try Cramer's rule one more time, solving for z. Okay, so pause the video and solve for z. I will have the answer here when you come back. Z is equal to the third column, the coefficient of z is the c's. I will replace that with the d values. A's will stay the same, and the b's will stay the same. And it is all over negative 6. Okay. I will multiply 3 by the 2 by 2 determinant of minus 3, 9, 3, negative 6. And I will multiply the negative of negative 2 by the 2 by 2 determinant of 6 minus 5, 3 minus 6. And I will multiply 1 by the 2 by 2 determinant of 6 minus 5 minus 3, 9. And remember to put it all over negative 6. Okay. So 3 is multiplied by minus 3 times minus 6, which is 18. Subtract 3 times 9, which is 27. Subtract negative 2 multiplied by 6 times minus 6 is minus 36. Subtract negative 15. And 1 multiplied by 6 times 9, which is 54. Subtract 15. And remember that it's all over negative 6. Okay, 3 times 18, subtract 27. That leaves us with a minus 9. And minus 2 times minus 36 plus 15 minus 21. And 1 times 54 subtract 15, which is 39. And all over negative 6. Okay, we're almost there. 3 times minus 9 is minus 27. Subtract minus 2 times minus 21 is minus 42 plus 39 all over negative 6. And what is that number in the numerator? Minus 27 minus 42 plus 39. And we get minus 30. It's over minus 6, and that is 5. So the solution in x, y, z coordinates is 2 minus 1, 5. This means that those 3 values satisfy each of these equations, and they are the only values that do. Thanks for watching.